It was a warm summer evening in Minneapolis. August 1st, 2007. Rush hour was in full swing. Families headed home. Trucks hauling freight. School buses, commuters, travelers all crossing a bridge they used every day without a second thought. But at 6:05 p.m. the I-35 bridge gave way. In just seconds, concrete, steel, and vehicles plunged into the Mississippi River. 13 lives lost, 145 injured. And an entire nation left asking, how could this happen in America? This is the story of a disaster that shocked engineers, reshaped national policy, and changed how we build and inspect our infrastructure forever. To understand what failed, we first have to understand what was built. The I-35 Mississippi River Bridge was opened in 1967. At the time, it was seen as a marvel spanning 1,907 feet, with a main span stretching 458 feet over the river. It carried 140,000 vehicles a day, connecting the Twin Cities and serving as a vital artery in the national highway system. The design? A steel deck truss bridge, efficient, sturdy, and cost-effective, but also vulnerable. By the early 2000s, engineers were growing concerned, not about massive flaws, but about the slow creeping stress of age, load, and time. Inspection reports began to use words like fatigue cracks, bending, distortion. Still, no one expected catastrophe. It began like any other day. Maintenance crews were doing concrete work on the bridge deck. There were construction materials, over 250 tons of equipment and gravel parked on the bridge's surface. By 6 p.m., traffic was crawling. Nearly 111 vehicles were on the span. And then suddenly, violently, it collapsed. Without warning, the center of the bridge buckled. Steel trusses snapped. Concrete slabs shattered. Cars tumbled 115 feet into the Mississippi. A school bus carrying 63 children was caught in the chaos. So were delivery trucks, SUVs, even emergency responders en route to other calls. Witnesses described the sound as a thunderclap, followed by screams, smoke, and sirens. In less than 20 seconds, the entire structure was gone. Tragedy often reveals the best in people. And on that day, heroes emerged. Bystanders jumped into the river to pull people from sinking cars. Emergency crews rushed to unstable wreckage to extract survivors. The school bus? Miraculously, everyone survived, thanks to the quick action of teachers, first responders, and the structural compartment of the bus itself. Hospitals were overwhelmed. News channels went into overdrive. America watched in real time as a modern structure failed before their eyes. The question echoed from every screen: how could a bridge like this just fall? The investigation began immediately, led by the National Transportation Safety Board, NTSB. Was it terrorism? Sabotage? A construction accident? What they found was more disturbing. The collapse had started at a critical connection point, gusset plate U10, a small flat steel plate that held together several truss members. That gusset plate? It was too thin. Instead of the required half-inch thickness, it was just 3/8 of an inch of flaw that had been there since 1967. Compounding the issue, more weight had been added over the years. Increased traffic loads, repaving layers, construction materials left directly above the weakest point. In short, the bridge was pushed beyond its original design limits, and the flaw finally gave out. It wasn't a terror attack. It wasn't sabotage. It was a quiet design error, hiding in plain sight for 40 years. The I-35 collapse shook the nation not just emotionally, but structurally. It exposed a terrifying truth. America's infrastructure was aging, and no one was watching closely enough. Within months, new inspections were ordered across the country. Bridges were evaluated. Gusset plates were reanalyzed. States ramped up load evaluations, especially on aging truss bridges. In 2008, Congress passed emergency funding for bridge repairs. The National Bridge Inspection Standards were rewritten to include detailed analysis of connection points, not just the large visible components. It wasn't just about maintenance anymore. It was about engineering accountability. The collapse also helped spark conversations around load testing during repairs, digital modeling of stress points, the use of sensors in smart bridges to detect early signs of failure. In essence, it forced engineers to rethink what safe really meant. The new I-35 bridge was built in just 437 days, a record-breaking effort. It opened in September 2008, equipped with built-in sensors, de-icing systems, advanced real-time monitoring. It became a model of resilient design, a symbol of how tragedy can lead to better systems. But for those who lost loved ones, for the survivors still carrying scars, And for the engineers who once inspected that bridge, the lesson was painfully clear. Even the most routine structure can hide critical flaws, and every bolt, every beam, every plate matters. The I-35W bridge collapse was not just an accident. It was a warning, a wake-up call, a turning point. It showed us that engineering is never static, that designs must evolve, that inspections must be relentless, and that sometimes the things we trust the most can fail when we least expect it. Today, infrastructure design carries the memory of that collapse, because behind every beam of steel and drop of concrete, there are lives. And those lives depend on getting it right. If you found this story eye-opening, give the video a like, subscribe, and share it with someone who still crosses a bridge every day without thinking twice. Because sometimes we need to remember